All right, now that we know how to use the compound interest formula, I think it's a good point to actually start doing some examples on this. So we're going to start with the following. We're given the total balance, and then we're given interest compounded annually. So that means that the total amount that we invest is going to be compounded every single year, so only once a year. And then we're given a period of time. So in this case, we want to calculate the total balance or the total amount of money that we're going to have after that period of time. So 4,000 times 1 plus 0.05. And we're going to raise this to the power of 10 because that's a total of 10 years. So we're going to plug this in our calculator. That's going to be 4,000 times 1.05 raised to the power of 10. And that's going to become $6,515.58. Now for the next question, we're given the amount, we're given the rate. But here, if you look very carefully, we're given the time period in months, but they're telling us in the question that the interest is actually compounded once per year. So basically what this means is that we need to convert this to years because we cannot just plug in 36 into the formula because that would give us a very wrong value. So in order to convert to years, we just divide this by 12, which is the total number of months in a single year. So it's going to be 3 years. So this is the value that we're going to plug into our n. So the new amount, the total balance, is going to be 25,000 times 1 plus 0.11 raised to the power of 3. And let's see what that's going to give us. That's 25,000 times 1.11 raised to the power of 3. And that's going to be $34,190.78. So be very careful with the way they present the information in the question because sometimes you might think, oh, I just plug this into a formula, but it's not really that straightforward. You need to really make sure that you understand what the question is asking. Because in this question, for example, we're given the same situation. We're given the period in months, but we're compounding the whole thing annually. So we need to convert this to years. So once again, we divide by 12. That becomes 5 years. And then we just plug in the values into our formula. So total balance is going to be 4,000 times 1 plus 0.07 raised to the power of 5. So plug that in the calculator, raised to the power of 5. And that's going to be $5,610.21. So I guess the tricky part here is to know how to interpret the question, because sometimes they will do this thing where they give you a specific piece of information, but it's not given in the right units, so you need to convert that into the correct units so you can plug it into the formula. Alright, so now let's look at another example. Richard borrows $200,000 from a bank for a total period of 5 years at an interest rate of 8% per annum. How much does he owe the bank? Well, in this case, we're given the original amount that was borrowed was $200,000, which is quite a lot of money. I'm guessing he bought a house or something. And basically, the interest rate is 0.08. And I'm going to assume this is compounded annually. So unless they specifically tell you something like it's compounded every month or per week or per day, you just assume that it's compounded annually. So that means that the number of periods that we're going to put into the formula is going to be just 5 years. So now the total amount he's going to owe is going to be 200,000 times 1 plus 0.08. And this is going to be raised to the power of 5. So now let's calculate that value into a calculator. 200,000 times 1.08 raised to the power of 5. And that's going to become $293,865.62. So you can clearly see that this is a massive amount of money to owe the bank. And the reason it is so huge is because the bank told Richard that the more he waited, the more this amount owed would be, because obviously the amount that he owes is going to increase by 8% every year that he does not pay that amount. So I guess this is why it is important to, when you borrow money from a bank, that you at least start paying it on the first year, so that the amount doesn't accumulate like this. And then you end up with a massive debt that is just going to be really hard to repay after that amount of time. And then the last question, we're going to have something slightly different. So we're going to find percentage increase in the following investment. So we're given $1,000 at 4% per annum, and this is going to be for a total of 5 years. So by percentage increase, all they really mean is, okay, so what is the ratio of the new amount of money to the initial one? So we're going to calculate the total balance. We have $1,000. Then this is going to be 1 plus 0.04, and it's compounded annually. And now we're going to do it for 5 years. So let's see what that amount comes down to. So that's going to be $1,216.65. Now, to actually find the percentage increase, what we need to calculate is we're going to subtract the original amount from the new amount. So we want to find out the difference between the two. So essentially, the amount of interest earned in any investment is going to be new value, or the new amount of money, minus the original investment, which was 1,000. So this is going to be equal to $216.65. So that's how much money he gained through interest. And now what we're going to do is we're going to divide this by the original amount. So the percentage increase is going to be the total amount of interest divided by the initial balance. So that's going to be 216.65 divided by 1,000, and that's going to be equal to 0.21665. Now this is expressed as a decimal. Remember, we want a percentage, so what we need to do is we need to multiply this by 100%. So in that case, this is going to come close to 21.67%. So that's by how much it increased at the end of those 5 years. And that makes sense because, see, if you take, okay, so $216 is about 21% of 1,000. So that's a reasonable amount. So this is how much he gained all those 5 years. So you can clearly see that even though the interest rate is just 4% per annum, at the end of those 5 years, he's going to have earned 21.67% of the original amount. So I guess in that sense, sometimes investing in some sort of savings account can actually pay off a little bit if you do it correctly and you account for all the things that are being included in that particular deal.